You'll have seen during the differentiation topic this table of derivatives here. So at higher you don't need to remember how to differentiate sine and cosine. You're told that the derivative of sine is cosine, and you're told the derivative of cosine is negative sine. The same is true with integration, in that we're given this table of standard integrals and we're shown that sine integrates to negative cosine and cosine integrates to sine. This should make sense because if we think of integration as the reverse of differentiation, we can see going back from cosine that takes us to sine. So cosine integrates to sine. We have to think a little bit harder here. Negative sine goes to positive cosine, so positive sine would have to go back to negative cosine, and that's what this is telling us here. It also tells us how to deal with a coefficient in front of the x, and it's showing us here to divide by that coefficient. Also, it's reminding us in both cases to put down our old friend, the constant of integration. So let's go ahead and use these rules. Here I've got three trig functions I want to integrate. I know I want to integrate them because, well, it tells me there, and this symbol in each of my questions is the integral symbol. So if I want to integrate 4 sine x with respect to x, I need to remember a coefficient doesn't have an impact on how we integrate. We're integrating sine. Sine goes to negative cosine. So the trig function is going to turn to cosine, and I'll change this to negative. My variable's just x, so I leave that as it is. And I have plus c, my constant at the end there. The next one, I want to integrate all of this in the brackets with respect to x. The brackets are just showing that this is one function and I want to integrate all of it. It's perfectly acceptable to write this without the brackets. So we deal with it a chunk at a time. A half cosine x. Well, the half is not going to change. Cosine, our table shows us cosine integrates to positive sine. Sine x. I've got negative 3 sine, so I want to put the negative 3 down. Sine integrates to negative cosine. So the sine is going to change to cosine x, and because this is negative cosine x, it's going to change my symbol. Negative 3 times negative cosine will give me positive 3 cosine x. There's 2 bits, but we can group the 2 constants together as a single constant at the end. The last one, we have got 2 sine x plus 4x. So it's not very common, but sometimes you'll be asked to deal with trig and non-trig functions mixed together. So I start by integrating the trig, 2 sine. Sine integrates to negative cosine. So that's going to go to negative 2 cosine x. The 4x, so the 4, that doesn't change. I've got x to the power of 1, so it's an implied 1 in there. I can increase the power by 1 and divide by that new power. So I divide by 2, or multiply by a half. Then I need to remember to put my constant on at the end there. The negative 2 cosine, that's not going to change. A half of 4 is going to give me plus 2x squared. And plus c on the end there. Now, the table shows us how to deal with a coefficient of x, and in these 2 questions here, x has got a coefficient in each case. I'm also going to show you how to deal with this plus pi, this plus 2, which isn't really mentioned here. I want to integrate 8 sine 2x plus pi with respect to x. The 8 is not going to change. Sine integrates to negative cosine. So I'm going to have negative 8 cosine. The thing inside the brackets is not going to change. 2x plus pi. The table shows me what to do with the coefficient in both cases. The coefficient of a, I just divide by that. So I'm going to have to divide by 2. The pi plus pi, it's got no impact on the integration whatsoever. I just integrate it as though it was 8 sine 2x. I just need to remember to have the plus pi in the brackets there. I also need to remember every time plus c. All that remains to be done here is to tidy up that fraction. So I've got negative 8 over 2. That'll go to negative 4. And the cosine 2x plus pi plus our constant of integration, all of that stays the same. Next one, same idea as one on the previous page. I have got some non-trig and some trig, so these two functions, and I need to integrate both of them. So I am going to integrate 2x plus 1 to the power of 4 minus 9 cosine 3x plus 2, and I'll integrate those with respect to x. So this is what we saw in the previous video, and this is what we're dealing with today. Deal with the first bit first. The bit inside the brackets, that is not going to change. I have to increase my power, divide by this coefficient here, so I divide by 2, and then I divide by my new power. So I have got 1/5. That's the same as dividing by 5. I have integrated this bit. I'm not going to write down plus c because I'll include it with the plus c from this bit here. Right, negative 9. Cosine integrates to sine. The table shows me there is no change in symbols. The thing inside my brackets, that doesn't change either. However, this is showing me if I've got a coefficient in front of the x, or whatever the variable is I'm integrating with respect to, I need to divide by that coefficient. So here I need to divide this thing by 3. So I'm just going to put the 9 over 3. Plus c, so this is the constant for both of these bits here. Fraction work, I'll need to tidy that up. So I've got 1/5 times 1/2, that's 1/10. The 2x plus 1 to the power of 5. 9 over 3, that just simplifies to 3. Sine of 3x plus 2 plus the constant of integration. So the plus 2 in the trig part of this has not impacted how we've integrated. The bit that's impacted how we've integrated is the 3, the coefficient of x. Looking at this one here, I've been asked to integrate 4 cosine 2x, and that'll be with respect to x, because x is my variable. If this was a differentiation question, it would be a piece of cake. because I would just set it up as 4 cosine x squared, and I would just hit it with the chain rule. However, there is no chain rule for integration. We cannot integrate the square of cosine x. So what we have got to do is we have got to use our formula list. We have got to replace cosine squared x with something that doesn't have the square in it. And this is where these rules from your formula list come in useful. There are 2 that have cosine squared in them. These 2 here. We've been told that cos 2x equals cosine squared of x minus sine squared of x. So all I'm doing here is I'm rewriting these without the a's. I'm using x's because I've got an x in my problem here. Or, using the other highlighted rule, I know cosine 2x is 2 lots of the square of cosine x minus 1. I could rearrange either of these to make the square of cosine x the subject. There's no point doing it with this top one. If I make cosine squared x the subject here, I'm going to have cosine 2x, and I'll need to plus that sine squared x over. And I basically replaced the problem of cosine squared with the problem of sine squared. So this is no use. This guy just needs to go away. The other one is a little bit more useful. If I rearrange him to get cosine squared x on its own, I'm going to end up with this. 2 cosine squared x is going to be cosine of 2x plus 1. Cosine squared x is going to be a half of cosine 2x plus a half. So what I've done here, I've added 1 to each side, and then I divided through the whole equation by 2. And I've got a useful identity here. I've got something I can use. I know instead of integrating this, I can integrate 4 lots of a half cosine 2x plus a half with respect to x. So all I have done is I have swapped out cosine 2x for what it is equal to. I've rearranged this identity and I've got rid of this square. I've now got something I can integrate. I'm going to multiply out the brackets first. So this is going to equal the integral 4 times a half, 2 cosine 2x plus 4 times a half gives me 2 with respect to x. This is now a piece of cake. This is what we've been dealing with on the previous page. This is where we can use the other part of our formula list. Dealing with the trig bit first. The 2, the coefficient at the front, that's not going to change. Cosine. Cosine integrates to positive sine. Sine of 2x. So remember, this rule is showing you ax stays as ax, that coefficient doesn't change. But it shows me also I need to divide by this coefficient. So I need to divide by this 2. Divide by 2. I've got the non-trig bit here. I need to integrate that. That is going to integrate to 2x. And then, last but not least, my constant of integration. Now remember, if you don't trust me on this jump here, think of it like this. We've got 2x to the power of 0. Because anything to the power of 0, this is the same as 1. So 2x to the power of nothing, I can increase the power by 1 and divide by that new power to give me 2x. So I have integrated properly there, trust me. All that remains to be done here is simplify down the fractions, same story as the rest of this. 2 over 2 is the same as 1. So I've ended up with one lot of sine 2x plus 2x plus our constant of integration. Our key takeaways from this should be, if we're integrating trig, use your formula list. There is no point wasting brain cells on memorising these rules if they're provided to you on your formula list. Also, for more complicated ones like the one on this page here, be prepared to use your trig identities where appropriate. And again, no point remembering those because they are also provided on the formula list.